Go ahead, sir.
Hello to fellow enthusiasts of space exploration and artificial intelligence. Welcome to Regulating AI's webinar on AI applications in space. We are honored to have with us today a true visionary in the field of astrophysics and the search for extraterrestrial intelligence, Dr. Avi Loeb. Dr. Loeb is the Frank B. Baird Jr. Professor of Science at Harvard University and a best-selling author. His illustrious career spans decades of groundbreaking research and leadership in astronomy and astrophysics. As the director of the Institute for Theory and Computation at the Harvard-Smithsonian Center for Astrophysics and the head of the Galileo Project, Dr. Loeb has been at the forefront of pushing the boundaries of our understanding of the universe. Today, Dr. Loeb is going to share his insights on the intersection of artificial intelligence and space exploration. His unique perspective, combining cutting-edge astrophysics with forward-thinking applications of AI, promises to offer us a glimpse into the future of space exploration and our search for other intelligent life in the universe, but also its implications on ethics and policy. The format for our audience is going to be that Dr. Loeb will provide his remarks initially, then I will have a few questions for him, and then we'll open it up to all of you for audience questions, and it should be a very interesting and fun afternoon. So without further ado, please join me in welcoming Dr. Avi Loeb. Dr. Avi?
Thank you so much, Sanjay. It's a great pleasure to join you. I will just show a few slides to set the grounds and then let you ask any questions that you might have. So let me share my screen and open my presentation. And what I will try to describe is the current status of the possibility of exploring space with artificial intelligence. Now, one thing to keep in mind is that if we want to go beyond the solar system, it's a long journey. It will take 50,000 years to reach the nearest star with the kind of chemical propulsion that we used, for example, in the case of Voyager or Pioneer or New Horizons, the spacecraft that we launched out of the solar system as of now. And AI was never used in space. In other words, all that we sent, for example, to Mars were robots, the Perseverance rover or the Ingenuity helicopter that are being operated from the Jet Propulsion Lab in Pasadena. And so that is a form of helicopter parenting. We did not allow probes to be autonomous in space. And of course, when you go on long journeys, there is no other choice because there is no way to transmit the relevant information in real time. It takes a long time for the signal, even at the speed of light, to reach Earth. And moreover, there is too much information. And the situation is similar to sending kids out of home. You expect them to report back whenever there is something really important, but otherwise, they should be autonomous. And these are our technological kids. And so they could report sporadically the highlights of their journey, but we want them to have their own brain and operate autonomously. And of course, we can design AI astronauts that would be resilient to the harsh conditions of space, including damage from energetic particles, cosmic rays, dust particles, or micrometeorites. And biological systems were not selected to survive in space. We have the magnetosphere of the Earth that protects us from cosmic rays, and we have natural resources here on Earth. We wouldn't be able to survive for so long on a spacecraft. Now, what are the challenges? Why haven't we used the AI as of now? It's twofold. The power supply is immense. The current large language models that are being used on Earth are heavy and require gigawatts of power. So the weight is a second issue. When you need so much power, gigawatts, the system must be very heavy, and it's not really feasible to launch it to space. Most of the current budget allocated to space is related to national security and therefore satellites that are close to Earth, and the AI systems can still be used on Earth, communicating or digesting information coming from satellites in proximity to Earth. That would not be a viable solution when we venture to much greater distances. And scientific space exploration, in difference from defense-related applications, is a low priority as of now. But given that less than 1% of the worldwide budget, $2.4 trillion for military expenses, is allocated to science. But I think in the long term, given the existential threats that we might have here on Earth, either from a giant impactor, an asteroid, or a giant solar flare that could destroy all the technological infrastructure that we have on Earth, it would be prudent for us to move away from Earth. And it's not just going to Mars, the way that Elon Musk is talking about. That could be a first step, but it's not sufficiently ambitious. We really want to go far from Earth on a platform that provides a habitat either for humans or just send our technological equipment in a suitable spacecraft. And in the long term, we can start by exploring the Moon, Mars, and beyond using a swarm of small probes. Each of them would be equipped with sensors and an AI system that analyzes data. And that would allow us to explore many different locations, even on Mars, rather than have a big system, a big spacecraft looking at one location. We can explore much more real estate this way. And once again, if those systems are autonomous, they will just report back essential information. The situation is similar to dandelion seeds, the flower that sheds a lot of seeds that are carried by the wind, and they arrive on fertile ground and can accomplish the task of reproducing the dandelion flower. And so in principle, we could even send self-replicating systems that could reproduce themselves, copying this idea from nature. For example, on the Moon or Mars, we might want to go to many places just to survey the water ice reservoirs that could serve as fuel. If you break the water molecule into hydrogen and oxygen, it serves as fuel. And to find the reservoirs that could fuel future economies, we might want to send a lot of such probes that have their own AI to decide what they're finding. We might also want to survey lava tubes. These are the places that we might put people in because they would protect them from cosmic rays and the temperature changes between day and night. Obviously these lava tubes are also interesting because maybe there are some prehistoric paintings if life became intelligent on Mars before it lost its atmosphere 2 billion years ago. So there are so many other planets that are habitable like Earth around sun-like stars in the Milky Way galaxy alone, probably about of order 100 billion of them. And then there are of order 100 billion galaxies like the Milky Way in the entire observable volume of the universe. So altogether, there are more habitable Earths than the number of grains of sand on all beaches on Earth. And given that we might explore some of those other planets, civilizations that may have predated us may aim to explore the solar system. And so we should search for any technological relics that they left behind. And even if the sender is dead, we could still find them. And over the past decade, the astronomers discovered the very first objects from outside the solar system. The first one that was announced was called Oumuamua because it was discovered by a telescope in Hawaii. And Oumuamua means a scout in the Hawaiian language. It was roughly the size of a football field. and its brightness changed by a factor of 10 as it was tumbling. And based on that, the astronomers concluded that it was most likely flat in its shape, not a cigar shape, but it had an extreme geometry, and moreover, it was pushed away from the sun by some mysterious force, and we don't know what that force was. Definitely not the rocket effect, because we haven't seen any dust or gas that you often find around comets. So it had many anomalies. It's still not clear what it was. It's possible that it was artificial in origin. I suggested that, but we just didn't have enough data. And we could get more data in the coming year or a few years from a new observatory. And I will briefly mention that. I should also say that the mysterious force that pushed Oumuamua could have been just the sunlight reflected off its walls, because a few years later, the same telescope in Hawaii discovered another object that was pushed by reflecting sunlight, and it was given the name 2020 SO, and it was found to be a rocket booster that was launched by NASA in 1966. So it was an empty shell with thin walls. That's why it had a large area for its mass, and was pushed by sunlight. So here you have an example of a technological relic that we produced, which behaved qualitatively speaking just like Oumuamua. And the good news is that next year, this telescope in Chile that is called the Rubin Observatory will survey the southern sky every 4 days with a camera that has 3.2 billion pixels, 1,000 times more pixels than your cell phone camera. And the camera is already on site. This is the way it looks. It's roughly the size of a person, the aperture of the camera. So it's very impressive, and there will be a huge amount of data in the pipeline, and potentially discovering an Oumuamua-like object every few months. And of course, AI and machine learning could be quite helpful in the search. And we developed relevant models with my postdocs to search for interstellar objects, because the thing that makes me most happy is having more data. I mean, it's very easy for people to say Oumuamua was a rock of a type that we've never seen before, and claim that it's natural, when the data is not good enough. But if the data will be good enough, we will know for sure that, whether it's natural or artificial. So the key in science is not to have a prejudice, but to collect, to be intrigued, to be driven by curiosity, to collect as much data as possible. I should also say the US government is reporting about objects whose nature is not known. These are called unidentified anomalous phenomena. And we built an observatory at Harvard University to collect data from the entire sky using an infrared set of cameras and optical, radio, and audio sensors. And we're about to release the first paper that reports results on 500,000 objects. We employed machine learning software to identify the objects, and we are looking for unfamiliar objects that do not look like drones, airplanes, balloons, birds, things that are familiar to us, just to see if there is anything else out there that might have arrived from an extraterrestrial civilization. We also went on an expedition a year ago to the Pacific Ocean to find the relics of the first reported interstellar meteor. That's an object 0.5 meter in size that collided on Earth a decade ago. It landed in the Pacific Ocean, and we were looking for the relics, the materials from this meteor. We did find the materials that had a composition different from solar system materials, and there was a paper published in a peer-reviewed journal just a couple of weeks ago detailing our findings. And our hope is that next summer 2025, we will go again on a more expensive expedition that will cost $6.5 million, where we would search for bigger pieces out of the wreckage of this meteor to figure out what it was, what was its nature, and whether it was natural or artificial. So this would be using a robot, a remotely operated vehicle with a video feed that would allow us to see in real time what we're picking up. And what you see here is a photo from the last day of the previous expedition, where I'm standing next to an 88 years old Art Wright, who was commander of a destroyer during the Vietnam War, and he was a real pleasure to work with on the first expedition. We hope to go again next summer. So that's all I wanted to mention in terms of background, and I'll be delighted to discuss any question you have about AI in space or about my research.
Well, thank you, Dr. Abi. This is really very, very interesting, fascinating, and groundbreaking. As a space buff myself, I find this incredibly insightful. So we have questions that will come in from the audience and are coming in, but let me ask you just to begin with. You talked about, in the past, you talked about interstellar objects being artificial in origin. How can AI help in identifying and studying such objects, Dr. Abi?
Well, it's relatively straightforward. What we are looking is for something that is not familiar. And so we are training the machine learning software that we have on things that are familiar. And as we get more data, the system will get better at identifying birds, airplanes, drones, balloons, clouds, leaves. And then if we notice anything that behaves differently, and that means in terms of its image, but also in terms of the way it maneuvers, the way it moves on the sky. And for that, it's actually very important to get the distance estimate. And the best way to do that is by triangulation, having two eyes or two sensors separated, looking at the same object from different directions. The reason we have two eyes in our head is because it's helpful for survival. If there is a predator, two eyes allow you to gauge the distance and escape the threat. So that's why people with two eyes survive better than people with one eye, or animals for that matter. And so we hope to have multiple sensors that will gauge the distance. We're planning to build two additional observatories in the coming year, in addition to the one we have at Harvard University. So altogether, we'll be monitoring the sky in 3 locations, scientifically speaking. And then the machine learning is a second step where we analyze the data. I should say that machine learning will also be important. I just submitted this morning a proposal to the Webb telescope to look at interstellar objects that will be identified by the Rubin Observatory next year. And the importance of the Webb telescope is that it's located 1 million miles away from Earth, 1.5 million kilometers away from Earth. So again, if an object comes by, it will look at it from a different direction. So that would allow us to pinpoint the 3-dimensional trajectory of this object and figure out if there is any propulsion, any other force than gravity acting on its motion. And so that will give us much better information than we had, for example, in the case of Oumuamua, where we had only the Hubble Space Telescope very close to Earth, not as far as, 1,000 times closer to Earth than the Webb telescope is. So definitely artificial intelligence is very important in the near term. In the long term, if we are visited by an intelligent probe, our AI system may help us figure out the intent of extraterrestrial AI system, and in fact might even have affinity to extraterrestrial AI systems more than to humans if it's made of silicon chips.
Mm. No, that's very, very fascinating. They might have more of an affinity to AI systems. Dr. Avi, space, we have a geostrategic thing going on in AI. Now we see that a little bit in space. The applications of AI in space, whether it's for national security, for others, what are for our audience, what are the rules of the road in terms of policies, regulations, whether it's on AI in space around the world? Are there any kind of rules, regulations that apply in this situation?
Well, it's such a new technology that no regulations were put in place as of yet. And of course, the first application would be using computers on the ground, on Earth, to analyze information that is coming from satellites. I'm sure that is already happening within intelligence agencies in trying to identify the kind of patterns you see in images of the Earth. What are we looking at? And that is very helpful in the battlefield. It's also very helpful in identifying movements that are about to result in something dangerous. For example, we know that there were two incidents in April and October where Iran launched ballistic missiles towards Israel, and I'm sure that the satellites orbiting the Earth were actually monitoring Iran quite carefully in anticipation of these launches, and that's why these ballistic missiles were not very effective. There were hundreds of them, so I'm sure that AI is already being used to analyze images and also to figure out patterns that the human brain is just unable to cope with, to do, because there is so much data coming in that you really need the help of a computer. But that is not the kind of thing I was talking about, which is to actually venture to great distances away from Earth where systems, probes would be autonomous. That's a completely different ballgame, because you cannot keep the computers on Earth. You have to carry them within the spacecrafts. And for that, the power consumption must be reduced by orders of magnitude, and the weight of the system must be reduced. And the human brain is just using 12 watts, which is quite amazing compared, and it has more connections by a factor of 100 to 1,000 than the best AI systems that we have right now, the large language models. So it's quite remarkable that biology was able to solve a problem of computation far more efficiently than silicon chips, the way we are doing it in AI systems. The artificial neural networks are much less efficient than biological neural networks. So we have a lot to learn from nature, but given the fact that nature demonstrated that you can do things with 12 watts, that's why we send astronauts sometimes to the moon and maybe even to Mars, because they need only 12 watts in their brain, But given that the problem was solved by nature to that level, it's possible that we will technologically accomplish the same feat. It's just that we are in the very early stages right now of AI development.
No, that's helpful. We've started getting some questions from the audience. So, Dr. Avi, one of the questions that's come in from Sean, I think, is what ethical considerations should we keep in mind as we develop and deploy AI systems for space exploration?
Yeah, so I think, first we have to develop the AI regulations on Earth, and there the ethical considerations, I think, should imitate what we use in the context of humans, because we are dealing with intelligent machines. And you can think of them as sort of a downgraded, as of now, downgraded version of humans, but in the future, they might be even better than humans in terms of their intelligence. The number of connections they have would be larger than the number of synapses in the human brain. So the way to deal with intelligent systems that that we had employed in the legal system before was to hold their parents responsible when they are still in the training phase. So when you have kids below a certain age, very often you hold the parents responsible for their actions. But once they leave home and start to operate in a way that goes beyond the training system, then you hold them responsible for it. And so, for example, if an AI system creates damage or commits a crime, similar to a human doing so, when they're still in the training phase, you will blame the manufacturer, the person who created it, or the company that gave rise to this AI system. But once it goes into the world and if it starts operating autonomously, you might take it out of commission. You might unplug it from the wall if it's not constructive to society. And there should be rules about that, about who to blame for mishaps and how to fix the problem, whether to retrain it on content that we find better than the content that it was trained on. Right now, large language models are trained on everything they find in the internet, and that's not a good approach because, I would never educate my daughters based on everything I find, in the dark corners of the street, at night, and that's really dangerous. And it's not obvious to me also that aligning them to follow the way humans think is the best path forward, because humans have a lot of faults. And just to give you an example, in the political landscape, what you find is polarization. You have tribes of people, let's say, on the right and on the left that make statements that do not make sense. And obviously, a more balanced point of view would be to go in the middle, because there are mistakes both on the right and on the left. But not many people do that. And therefore, if you wanted to train an AI system, it will be trained mostly on the extremes. And if we want the world to be better than it is right now, we better train the AI systems on values and guidelines that would make the world better and not polarized as it is right now. This is just one example. But also in science, most of the scientists that I know, and, I've been practicing science for half a century, most of them just follow the beaten path. They don't innovate. They don't think creatively. They don't ask questions that deviate from what everyone else is saying. And if you wanted to, explore new or make new discoveries that are not recognized by human scientists, you want to train an AI system to think critically, given the data, and consider possibilities that are out of the box. And if you just train it on human content, you will never get that. So I think we should think more broadly about using AI. It's definitely not. It's not the same as natural neural networks, because we are made of flesh and blood, and AI systems are made of silicon chips. So I call it alien intelligence. AI is also alien intelligence. And when we try to align it with the human thinking, it's sort of like putting lipstick on a pig.
Putting lipstick in a pig, that's interesting. Dr. Avi, this has been tremendously helpful. Towards the end, we have a lightning round of questions, just one-word answers. A little bit of interesting nuance. So, are you ready?
Yes, please go ahead.
Okay, one-word answer. So, most exciting AI application in space exploration.
Searching for life.
Okay. Timeline for AI-driven interstellar probe.
Probably a few centuries from now.
Oh my gosh. Okay. AI or human astronauts for Mars colonization?
AI.
Okay. Likelihood of encountering AI from another civilization?
Very high if we search. We may have it already. It's just that we haven't really studied the evidence.
Oh, we may have it already.
Yeah.
I better be
I mean,
careful.
I'm talking also about the US government has things they don't understand. And they put a very high classification on it. And so scientists like myself do not have access to it. In a month, there will be a hearing about unidentified anomalous phenomena at the US Congress. And stay tuned, it will be interesting.
Okay, we'll be watching. Most important sensor for AI in space.
Cameras and possibly 3D printers.
Cameras and 3D printers. Okay. Dr. Avi, Mars or Moon?
Mars.
Astrophysics or cosmology?
Cosmology.
Final one, and I think I know the answer. Extraterrestrial life, yes or no?
Yes, definitely.
Wow, that's why we better be careful.
I mean, it would be arrogant to think otherwise. Yeah,
it would be arrogant to think otherwise. Absolutely. So as we conclude this fascinating webinar on AI applications in space, I want to really express our deepest gratitude to Dr. Avi Loeb for sharing his profound insights and really visionary perspectives. Dr. Loeb's expertise has illuminated the incredible potential and challenges that lie at the intersection of AI, space exploration, ethics, policy. And as we look into the future, it's clear that AI will play an increasingly crucial role in pushing the boundaries of our understanding of the universe, from our ability to detect exoplanets to potentially assisting in the establishment of off-world colonies. The symbiosis between human ingenuity and AI promises to really unlock new frontiers. So we are at Regulating AI, committed to making sure the ethical implication, potential risks for relying on AI for critical space mission require careful consideration and ongoing dialogue. So thank you again, Dr. Avi, and to all our attendees and to everyone who has participated in this enlightening discussion. May this webinar serve as a catalyst for further exploration, innovation, and collaboration in the exciting realm of AI application in space. Thank you so much, Dr. Avi.
Thank you so much for having me. It was a great pleasure.
Thank you.